Assalamualaikum and greetings to Dr. Hazina and my fellow friends. Today, our Group 3, will be presenting about virtual mouse based on hand gesture recognition. So, without further ado, let us dive into it. Okay. Here are our group members: Shasha, Hanis, Kaisa, Alia Maisara, and me, Irdina. Okay, so what is exactly virtual mouse? To make it simpler, a virtual mouse basically is for us to be able to operate a computer cursor without a physical or manual mouse. So in our project, we will be using hand to control our cursor. Okay, that's it. Thank you. Okay, so why do we need this virtual mouse, right? This is because we want to reduce the percentage of people getting carpal tunnel syndrome. What is this carpal tunnel syndrome? It's actually a wrist and hand complaint. It's like hand and wrist complaint due to repetitive things that we do. For example, if you are like a office worker or a student ourselves, we will be using lots of like mouse like that. So it will affect a long time effect lah to our hand like that. So these are the details about the carpal tunnel syndrome. Basically, it will be affecting our wrist, so it's very dangerous. Another why we should use this virtual mouse is because we want to make our real time life easier. Which, for example, as a lecturer, we want to control our cursor from behind of the class, so it's a bit inconvenience for you to keep on moving to like move. So we want to easier your way like that. Okay.
Hi, I'm Shasha and I will explain you about the objective of the projects, the goal of the projects, and the loading data which is in the pre-processing process that I will explain it later on. So let's focus on the objective first. So as the past presenter state about the problem statement, we as the developers came up with the solution by having a firm objective, which is to develop a virtual mouse that can replicate the core function of the traditional mouse, which is this that can click, left click, right click, scroll up and scroll down, but by using fingertip movement and hand gesture only. So how we do it? So we utilize a web camera that can capture hand gesture and fingertip motion. So the system will process this input to enable the core function of the traditional mouse. So this include the function that I said just now, left click, right click, and the scroll up and scroll down functionalities. Okay, that's all for the objective part, and let's move on to the goals of the projects. So basically, what is our goal of the projects? So we decide to choose and set the goal of our project, which is to train the machine learning algorithm or model to recognize different and variety of hand gesture and movement. So what is the key goal? The key here is we want to identify and classify the each gesture of the hand, like the palm and then the fingertips of each finger, thumb finger, index finger, middle finger, index finger, and pinky finger. In this era, Society 5.0, we have advanced technology and we choose to use convolutional neural network CNN, which is a type of deep learning that we'll explain later, so don't worry. And then tools like TensorFlow and Keras. And that's all for our goal.
Hi, I will explain to you about the MediaPy, which is MediaPy is an open source framework for building pipeline to perform a computer vision inference over arbitrary sensory data such as video or audio. I will explain to you about the flowchart. Starts with the input frame GPU at the top, indicating that it's processing input frame using GPU. Image transformation box is connected to the input, showing the initial step involved transforming the image. Hand detection box indicates where the system detects hand within those transformed image. Detect hands data, non-react flow into the to render data, converting detecting data into renderable format. render data, then move to the detection to render data, preparing it for overlay annotation. Finally, annotate render data, annotation overlay, produce an output frame GPU, which is are the processed and annotated output frames ready for the display or for the use. So, we can use the MediaPipe, which is machine learning ML teams, and also the software developer, which is we also a student can use that, and also a researcher. And then what is used for? First, we need to know our task, what we choose, which is my team choose a vision, and then choose your platform, which is for this visual mouse, we choose a Python, and then we choose a Python to develop our environment, and then to understand the available solution, which is the output and inputs, and will be explained it later. Then develop our application, which is a virtual mouse, and then the concept of MediaPipe. There has a three framework, which is a framework, a set of tool and reusable components.
Okay, right now I'll go through about OpenCV. What is OpenCV? OpenCV is a cross-platform library used for develop real-time computer vision applications. It mainly focuses on image processing, video capture and analysis, including features like face detection and object detection. In our project, it is hand detection. Okay. What it is used for? It is used for image processing, video capture, and analysis, as it provides a wide range of functions for image and video processing. It supports reading and writing image and videos in various formats. Basic operations like resizing, cropping, rotating, and changing colors, pieces can be easily performed. Okay. Now, the features of OpenCV in hand recognition. Firstly, hand detection and tracking, as it provides tools for detecting and tracking objects in image and video streams. In the case of hand recognition, this involves detecting the hand within the video feed. Techniques like such as background subtraction, color-based segmentation, and contour detection can be employed to identify the hand in the image or a video frame. Okay. Once the hand is detected, OpenCV can be used for feature extraction. This involves identifying key points and mark or distinguishing characteristics of the hand. OpenCV's algorithms can assist in extracting relevant features such as fingertips, palm location, and finger orientation. After that, OpenCV facilitates the implementation of gesture recognition by analyzing the hand position, movement, and configuration over time. Algorithms can be designed to recognize specific gestures like pinching fingers or a click and menu. Next, OpenCV also enables the mapping of hand movements to mouse cursor movements. By translating the detected hand position and gestures into corresponding mouse action, virtual mouse control can be achieved. The PyAuto GUI library that we use in our Python code is often paired with OpenCV for mouse control based on hand gestures. Lastly, OpenCV allows for real-time visual feedback by drawing on the video frames. For example, um, it can draw circles around detected fingertips or highlight the hand's position on the screen. This feedback aids in understanding how the hand movements are being interpreted and allows for debugging and improvement.
Hi, my name is Kaisa, and now I would like to focus on what is deep learning. So, deep learning is actually a subset of machine learning. So, just imagine like machine learning is like a toolbox. So, this deep learning is one of a toolbox. So, and
uses artificial neural network with multiple layers for representation learning. So what is multiple layers? So how does it work? It's actually like multiple layers work just like as filters. So it will filter each photo to detect it features like, okay, this okay, the first layers or the first filters will try to just look and finding and do tasks, like maybe like try to find a curve, like our hand curve, like, oh, these pictures have like 4 curves, let's just like that, and we'll go more to the next layer, and the more further the layer it will go, and the further layer would be accomplishing the complex task. Just like, oh, just the first layer, just like try to figure out the age, the curve, and but the like last layer might be try to determine the line of our palms, like, oh, it has lines, just like that. So that is why it called as deep learning, because it actually go deep just to learn something, to learn the data that we give. It can be like supervised or unsupervised. So what does it mean by supervised and unsupervised? So supervised means that we'll tell the deep learning that, okay, this is a picture of cat. We give them the picture and we tell them directly. And while the unsupervised means that, okay, this picture, just find yourself what is it, just like that. And then it is based on the use of layers that process the input data and extracting features. So this is what I just explained just now, but I want to explain more, just like try to sync these things is like a detective. So each layer have their own detective, and the first detective will be finding the simpler clues, while the next layer would be the more complex, and the more complex is like that. And then, okay, from them and producing our mathematical model. So after they tried finding the features, like from the simpler features to the most complex one, and then they try to do the mathematical model. What is this? This is like a prediction and also decision, yes. And then deep learning models can recognize complex patterns in various types of data, allowing for automation of tasks that typically require human intelligence. So what does it mean? Does it mean like they can do what human brains basically can do? So for example, like a doctor like, okay, this patient have like cancer. So this deep learning also can detect the patient have a cancer as long as they see the image of X-ray of the patients, just like that. And sometimes they can even notice something that a human can't notice. Just like maybe the doctor missed something like very detailed or very small, but this AI can actually finding and know, oh, this is actually, you missed the detail. This patient actually doesn't have cancer, it's just a tumor, just like that. And then in this specific project, in our project, we'll be aiming to classify different images of hand gestures, which means that the computer will have to learn our movement. Okay, so CNN, or also known as convolutional neural network, is one of deep learning that we use. So this CNN is actually the part of like artificial neural network. So it works as same, which is like they do the recognition, they do the layering and many more, but the most important part, they also do the classification. So they don't just, after like they they detect the features of every data that we give, it's just start to classify, because our hand is just not always like this. It's not like we always like this, we eat like this, not. It always have a movement, it always do the movement, and of course this CNN will always like try to classify the each move or shape of our hand gesture. So if we show this, it will classify it as a face, and if we show this, it will classify them as a piece. Just simple as that. And CNN is also known of the tools that is specially built for classify or also knowing the image, analyzing the image, knowing the image, recognizing the image. Yeah, just like that. Basically recognizing the visions.
So here is the pre-processing process, which has 3 stages, which is the loading data, and then creating model, and the last one is testing model. So I will explain the loading data part. So let's move on to the first step, which is loading data. Okay, so here is the loading data part, which is the first step to train the machine to be smarter. So in this project, we decide to use hand gesture recognition database that available on the Kaggle. Why we use it? Because this dataset contain 20,000 images that have a variety of hand gesture from 10 different people and split off between 5 female and 5 male. And this image was captured by the lip motion hand tracking device. And as you can see here, the column, the table here, which it has hand gesture and label. So we have specified what we want to recognize the hand gesture, which is thumb down, palm horizontal, L shape, fist horizontal, fist vertical, thumbs up, index finger, and OK shape, palm vertical, and lastly the C shape. So each gesture was labeled with different numbering because it's easier to classify each gesture. Here is the code. So here is the code for the pre-processing process, which is loading data. So I will explain you part by part because it will make you understand better. So the first step, we need to initialize an empty list because we want to store the path of the image files. And then we need to iterate through the current directory and its subdirectories. And then you see the for loop function, which is we want to loop through every file in the current directory. And then if you can see here, the if function that will check if the file is a PNG image or not. So if the file is the PNG image, it will add the path of the PNG image into the list. So the last step is it will print the total number of the PNG image that was found. So that's all for the first part of the code. And let's move on to the second part, which is the general idea is the function is used more for debugging and to show the result later. So the first thing first, you need to define the function of the plot image, which take an image path as an argument. And then what we do, we use OpenCV to read an image from the given path into the NumPy array. And it will convert the image to the correct color space, which is grayscale. And it will call the print function, which is it will print the dimension of the image for the verification. So as you can see here, which is we disable the grid to enhance the image visibility because we want to see better. And then we will display the grayscale image. So as you can see here too, we label the X label, Y label, and the title. And that's all for the second part. Okay, let's move on to the last part, which is the most crucial part. So the first thing is we need to initialize X and Y. So X for the storing image data and Y for the labels. So let's move on to the for loop, which is first thing is we read image and return to NumPy array, and then it will convert into the grayscale, and then it will resize because when reduce the size of the image, it will better and faster for the training process. And then the resulted image will add it to the X because X is for storing image data, right? So let's move on to the processing label in image path, which is we extract the label for the file path and adjust to the specific name and add them to the Y because Y we store the labels. And the last part, which is we convert X and Y into NumPy array to speed up the train, test, and split process. So how we do that? We reshape the X to the required format for the C and N, and then it will print the count of the loaded image and the labels loaded. And for the last line, which is it will print the first label and the path is for the debugging purpose. That's all from me for the loading model.
Okay, I will continue to explain about the creating model. On the left picture, we have the input layer, intermediate layer, and the output layer. Input layer is when we receive the data which is image that is used to train machine. Next is intermediate, things that we need the machine to learn the pattern. This is part where we put all those filters. Then output layer is when the final prediction or decision produced based on all the nodes from the previous layers. Then only we can obtain the either yes or no. So we just discussed about the basic layer of CNN. Let's move on to the construction model on the right picture. So we use four layers in here. Firstly, there is convolutional layer, conv2d. Okay, why 2D? It is because every image consists of weight and height. So that is why we use 2D. If you look at the code, you will notice three pairs of convolutional and pooling layers. Why it is three? It is because every image color base are red, green, and blue. It will go through each of every color starting from red and then green and lastly blue. Then look at the that 32, 64, and 64. It determines the filter that is used. Okay, next, activation of ReLU. That stands for rectified linear unit. It helps to focus on the relevant information. If there is relevant information, then keep. If not, it discard it. It prevents from the waste of data. Convolutional basically is to find the important features of the image. From there, the input image will be targeted or focused more due to the activation function as well as the size of the size will be reduced as you can see from 5 to 3. Other than the targeted image, it will be totally discarded. Okay, next, after it's true that it received the data, pooling layers shrink the picture down to focus on important parts. So max pooling there will expand the shrink image that is used again and again discard anything else that don't need. After that, we have the flatten. As I said just now, every image consists of three layers, red, green, and blue. Each color depends on intensity that will determine the final color of the output image. It is similar to the matrices concept that we have learned before, where from one matrix to another matrix, we perform calculations, then only we get the final answer. Then we got dense. Basically, to determine the output. After go through flatten, dense will determine what is the prediction of the output. The last one, the code, at the both pictures, it just explain where which the data is divided to go through the training process. So as you can see, we got two models that we use in our hand recognition, which are form detection model and hand landmark model. These two particular models is used to train the machine to basically detect our palm and our fingers.
Okay, now that we have the model compiled and trained, we need to check if is it good. First, we run a model that evaluate to test the accuracy. Then we make a prediction and plot the image as long with the predicted labels and true labels to check everything. With that, we can see how our algorithm is working. And here is the result. Then we produce a confusion matrix, which is specific table layout that allow a visualization of the performance of an algorithm. And here is the result, which is we comparing the predicted and also the actual.
Thank you, Sarah, for the great explanation. Now, you must be wondering behind all those techie stuff, what and how actually they detect our hand. How do they process the images? So here I will be explaining to you about how. Okay. So here are the concepts. Like the first one is hand detection. The second one is the fingers and palm segmentation. The third one is the fingers recognition, and the last one will be the hand gesture recognition. Okay. So let's dive in. Okay. The first concept will be hand detection. From the first figure, the figure 1, it shows the hand images captured by our web camera. Even either with or without noises, can be like environment noises, human noises. The skin color will be used to discriminate the hand region from the background. Okay, which is our hand will be measured with the HSV model. As you can see, that the HSV, the hue, saturation, and value. Okay, then after that happened, you can see the result at the figure 2, which where the white pixels are the member of the region, hand region, and the black one is the belong to the background. The second step will be the fingers and palm segmentation. So we will be referring each of the box as pixel. Okay. So the palm point defined at the center of the palm. So this is the palm point defined at the center of the palm. Okay. Here we use a distance transform method which calculates the distance of each pixel in the binary image. So as you can see, the figure 3A is the binary image. Okay. So we want to calculate the distance of each pixel to the nearest pixel with a different value. It's like 0, 1, 1, like that, plus 2, 2, 2, plus, okay, next one. Yeah. Okay, so as is shown in the figure 3B, it's like after we have done the distance transform, this is how it will look like 0, 1, 2, 3, 4. We will be seeing the center of the point of the binary image is the largest distance, which is 4, and that will become our palm point. Okay, so then after we know where is the palm point, we can find the inner circle of the maximal radius. So how do we do that? Okay, we mark the palm point as red, as you can see the figure above. We mark it as a green one, then we will expand the radius from that point into the palm, which where it will stop. It will keep on expanding until it found until the black color background get into the circle, then it will stop. Okay, so after we know the palm point, the maximal radius and all, we can have the palm region there. Then we connect all the distance and numbers there, and we make a palm mask. So we know that is our palm region. Like that. Okay. So then you can see the video above, like this is the picture. The video okay, that will show how the hand is detected. Like we put our palm there, got the green mark and move around, and it when the palm point and wrist point are obtained, it can yield an arrow pointing from the palm point to the middle point of the wrist line at the bottom of the hand. Okay. Then the arrow is adjusted to the direction of the north. The hand images rotate synchronously. Okay, so as to make the hand gesture invariant to the rotation. Okay, so here you can see the rotated and cut hand image lah. The one with the complete one. Okay, so this the rotated and cut hand image, the parts below the wrist line in the rotated image are cut to produce an accurate hand image that does not enclose the part of the arm. Yeah, because we need to be accurate. In order to detect each of the fingers, we will be using a labeling algorithm. So, okay, they will detect regions in which the number of pixel is too small, which can be like the between the finger and all. So they will just discard it. All the noises will be discarded, okay, and the region that is not your finger will be just gone like that. So each remain region that is a finger, the minimal bounding box is found to enclose the finger. As you can see in the figure 9, there got box around the finger. That then the center of the box will be the center of the finger. Okay. Okay. So for next one is the how we detect each of the finger is white and white lah kan. Okay, so right now we will be trying the thumb detection and recognition. Okay, so how do we do that is that from the bounding box, near the center of the box, we will be align it with the palm point. So if the degree is more than 50 degree, then it is the thumb, because our thumb is quite short than other, so the degree will be smaller lah than the 50 degree. But if larger than 50 degree, then it is other finger. Okay. So how do we recognize the other fingers? Okay, it's from the first we need to search for the palm line first. Okay, for this palm line, we will be searching for the wrist line first. Okay, from the wrist line, we will go by pixel to search. Okay, if the white region is still there, then it will go up and up and up by pixel until it come to the thumb region, and it will stop, and then it go up again, up again, yeah, up again like that. So then we can see the palm line lah, it connected into two. Yeah, you can see on the figure 9 there. So after we find the palm line, it will be divided into the 4 parts. Okay, it will be divided according to the horizontal coordinate of the center point of the finger. Okay, as you can see in the figure 10, it falls into a certain part. If the figure falls into the first part, as you can see that, it is the forefinger. If the finger belongs to the second part, it is the middle finger. Okay, the third part corresponds to the ring finger. The last part will be resulting to the little finger. Okay, the pinky one. Okay, then the result of the finger recognition of the first picture, the first, the webcam picture and all, can be seen here. Okay, the yellow line is the palm line, and the red line is the line that is parallel to the wrist line.
Hi, I am Haris Naisha and I will be explaining about the interface code. So firstly, we need to import Streamlit and name it as ST. Okay, Streamlit is a package that we use to design our interface. Then st.title is the title that we're going to put in our interface. Okay, and then okay, we are going to define the method virtual mouse control. And from line 12 until 69, it will be discussed and explained by Kaisar later. Okay, get back to the interface. We have the one and only button, which is try virtual mouse button, and then it will call the virtual mouse control at the line 11. So this is our output. So I'm going to click the button and it will take some time. Okay, now you can see me and Okay, my palm is already detected, and later on it will be discussed further by Kaisa.
Hi, it's me again, Kaisa. You see me again. So now I would like to show you the testing or how we actually do our code to run this visual mouse. So first of all, of course, we import three things. So what is this thing? It is CV2, MediaPipe, and Pi2GUI. So CV2 is used to open the camera, MediaPipe is used for hand tracking, and Pi2GUI is used for control the mouse. So okay. Now we open the camera, we capture the camera, create instance for MediaPipe, we drawing utility, basically just like initial declaration, and then we start to use the while true. So this while true is actually a looping to keep this coding to process the image or the input that we get from the frame, this frame, and then we continuously like cap.rate is actually read, right? Okay, whatever. Continuously capture the frame from camera. Okay, and then we flip this camera horizontally like the mirror effects, and then we get the size of this frame by using that frame.shape, and then yes, we need to convert what we got from this frame into the RGB. So what is actually the RGB? So RGB is like red, green, and blue. So red, green, and blue. Okay, red, green, and blue. So why we need to convert it? Because this MediaPipe needs to use this format of red, green, blue to actually identify the movement and the hand gestures, and yes, like that. And then we start to process. After we convey, of course, we process the RGB frame using the MediaPipe hand detector, and we detected landmark, stored in hands variable like that, and we start to do the selection like if hands. So it's mean like as long if this frame detect our hand, so it will do this code. So the first code is like looping again, so it will like keep do this code as long as it has a hand, it detects a hand. So the first thing is drawing utils dot draw landmark, so it actually draw the landmark. So what is landmark actually? So the landmark is like red dot, like dot 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 dot. So that is the landmark, and then we get this landmark, and then in line 25 we for ID landmark enumerate. So okay, actually landmark is have their own value or number, like it will never change, never like if you have like big palm, if like tall fingers, it will always be the same, it will never change, it will be stay this 0, this will be the 1 2 3 4 5 6 7 8 and until 20, it will never change unless you have like 6 fingers. Then MediaPipe actually will be confused. But if you have 5 fingers, so that is will be the index of your fingers. So and then we start with to find the x and y coordinate. So we assign it with the x and y variables. So how to find it is actually like landmark.x times frame width. So as we know in basic math, x is basically like the vertical, no, the horizontal line, which is the width, and y is like vertical line, which is the height. As simple as that. And then we go to the very first coordinate that actually will move the cursor. If ID is equal to 0, so when I say this is 0, so it will never change. It will always be in your palm. It will be never be in your teeth. It will always be in your palm. So yeah, we don't need to assign because ID is equal to 0. It will be your palm. So we want to create a small circle. So in line 30 is actually we try to code to with a circle. So set as 1, radius 10, color 0 to 55 to 55 is actually a code to make it a yellow color. So then we try to assign or we do the formula, which is the small size of the last size of the small size time by the distance. So this means like we want to move the cursor in entire screen, not only in the frame. So we need to get the coordinate of the screen, and then we use the Pi2GUI.move tool. This is actually the method or the function method, I think, to move the cursor by using our palm. And then if I run this, Bismillahirrahmanirrahim, please. Okay, nice. Okay, so if you can see this is my palm, this is 0. It is a little bit lagging, but as you can see, the cursor is actually moving, and in my other hand, I don't actually I don't actually, let's say I put it here, I don't actually it detect both hands. I don't know how to make it like prove that I don't actually move my mouse traditionally. So okay, just like that. Okay, and then we go to the next code, which is this thumb finger tip. Okay, this is like a code just to like detect the thumb finger. It doesn't have like any movement or moving the cursor actually, because we need to move it, we need actually these 4 fingers to have it functions. So we have like middle finger tip, this is middle finger tip. Like this, we want to scroll up its side. As you can see, like pi to GUI, scroll like that. Yes, this is like to scroll basically. And what does it mean in like the line 44? If adds middle Y to my thumb Y less than 40, it's mean like if the gap is less than 40, it will like try to scroll up the function, yes, right? And it will happen the same thing with the ring, index fingers and pinky fingers tip. Oh, this is a ring and this pinky finger tip. So
Who do you want to call?
okay, so pinky is for like perform right hand clicks and left hand click. Sorry, this is like to scroll down, left hand click, and to scroll out the website. Okay, so that is basically how to do it. Okay, so now I will show you again like how I'll do this. I hope it works. It's actually work, but a little bit lagging. So as you can see now, I want to move to the basically food. So I want to left hand clicks. Okay, so this left hand click is a little bit okay. If I right hand click, it will go and I want to open, and yes, it basically open. So now, what if I want to scroll down? Can you scroll down?
I want to try to move the stationary mouse just to make it easier. Oh my god, I forgot that I forgot to turn on the Bluetooth. Okay, so okay, this has to like scroll down, so I'll scroll down.
Yeah, it can be scrolled down. It takes time. Yeah, it can be scrolled out. Alhamdulillah. Okay, so that is basically the example. So, okay, I think that's all from me. Oh, before that, the last of our code, we have like CV2 dot show virtual mouse mouse frame. So this is basically a code to display the frame with the hand landmarks. That is the code, and we have like CV2.wait key, which is like wait for a short time before capturing the next frame. So that's why it keep lagging, I think. Okay, so yeah, that's all from me. Thank you for watching us. So yeah, thank you. Bye bye.